Alright, so last week we learned about parent functions, and this week we're going to learn about one specific one, and that's the absolute value function. So we already know that the shape of the absolute value function is a V. So today we're going to talk about how to come up with the equation from a table and how we can come up with the equation from a graph. So let's first start by talking about some vocabulary terms. So remember that absolute value is the distance a number is from 0. So when we say the absolute value of x, we mean that it's always going to be equal to x and it's positive. Alright, so an absolute value function has a vertex at the place where the two lines intersect to form the V. This is also the point that splits the graph symmetrically. So we kind of saw that last week when we were graphing all these functions, that there comes to a point and it makes it symmetric. So the definition of a vertex is a point where the axis of symmetry, meaning the line that splits it in half, intersects the graph. And we can say that it's located at h and k, which comes from our equation, the absolute value of x minus h plus k. And there's an a value here. Okay? So we're still talking about the same letters that we've been talking about all last week, but now we're being more specific with which function we're talking about. So let's go ahead and look at determining the equation of a graph from a table. So if we are looking at this table, we can say that, alright, well, these are going up by 1, and these are going up by 1. That tells us that these are linear functions because they have a slope of 1. They have a constant change. But look what happens right here. So at 4, the graph goes from decreasing back to increasing. What that means is that there's a change in the graph. It's not a straight line, it's changing. So if we were to sketch the picture of this, we have a point -3, 1, 2, 3, and 4. That's a change in the graph. So the dot on this side of it at at -4 is at 5. And the dot on this side of it at -2 is also at 5. That's what creates the V shape, and that's why we know it's absolute value instead of linear. So the equation of this function, we know that this middle point where it changes direction in the table is the vertex. So the equation of the function is the absolute value of x minus a -3, which becomes +3, in plus 4. So this is why, again, we remember you change the sign of the h value. So remember that h goes with x, k goes with y. So the vertex of the equation is at -3 and 4. The vertex is where it changes direction. Alright? We can also determine the equation from a graph. So say we have this graph. First thing we note, it's upside down, so that means it's been reflected. Alright, we have to add that into our equation so that we don't forget that it's actually going upside down. Then the next thing that you're going to do is determine the vertex from the picture. So if I count over 1, 2, 3, 4, that's 4. 1, 2, 3, 4, 5, 6, that's at 6. My vertex is that point right here. Because if I were to draw a line down the middle of it, it makes the graph symmetric. I can fold this side of the graph onto that side of the graph. So that tells me that that's the vertex. And so we can now easily write the function because remember this is h and this is k. So we can say that f of x, meaning the function value at x, remember we reflected it so it's negative, is the absolute value of x minus 4, because remember the h value is opposite of what you think, then plus 6. That's easy enough, right? And with the vertex we already found on the graph, so it's at 4 and 6. So just giving a little bit more definition to our graph, knowing the vertex, we can easily come up with the equation from a graph and from a table. Now we're going to practice this on Monday. If you're still a little confused, rewatch the video. But otherwise, write down some questions, bring them to class Monday, and we'll talk about it first thing. Hope you had a great weekend. Make sure you fill out the WSQ.